Hi everyone, welcome back to another pre-calculus video. Today we're going to be looking at how to solve trigonometric equations, and how we're going to do that is we're going to be solving using square roots. So I know this might be a new notation for some of these problems, and you might not be aware of how it's supposed to look for when it comes to trig equations. But this right here, this little square, just all it means is that the entire function, the entire cotangent function in this case, the entire function gets squared. But instead of writing all of that notation, what we do is we just put the little square or cube or to the fourth power, we put it just in that little indentation right there. So that tells us that it's being squared. It's not a different type of function. So as I'm going through this, what you're going to want to do is kind of like the last video that we had done. If you haven't seen the last video on isolating your trig functions, make sure you go and watch that video first, because this is a continuation of those notes. So in this video, what we're going to be doing is the same thing, isolating the trig function, but then we're going to have to take that square root. So let's isolate the trig function first. So we'll subtract 4 on both sides. 3 cotangent squared of x equals, that zeroes out, 7 minus 4 gets me 3. Divide both sides by 3. And I get cotangent squared of x equals 1. Now here's where that square is going to come in. Before you can take the inverse trig function, and inverse cotangent in this case, what you're going to want to do is take the square root of both sides. So since it's squared, in order to get rid of that square, or again, if it's a cube or fourth root, you just take that square root. Now there is going to be, as I write this out, there is going to be one thing that you're going to want to keep in mind. And I say this all the time. Whenever you're taking the square root to get rid of the square, you end up with 2 possible solutions. Now there's a lot more involved with that, with absolute values and such, but we're not going to get into that. What you need to remember, what you need to recall in this case, is that whenever you take the square root of both sides, you end up with a positive and a negative solution. So what's the square root of 1? Well, the square root of 1 is 1, but here we're ending up with a positive 1 and a negative 1. So we're going to have to solve for both in this case. So let's look at this now. We're going to want to take the inverse cotangent function of both sides. So x is going to be equal to the inverse cotangent of positive and negative 1. So we need to solve for all of those. Now if you remember from the unit circle, cotangent are my x over my y values. So if I'm getting a positive or negative 1, I am dividing by the exact same thing. The only time that happens on the unit circle are those pi over 4 sections. So pi over 4, 3 pi over 4, what was this? 5 pi over 4 and 7 pi over 4. Because whether they're positive or negative, the x and y doesn't matter. They're being divided by the same thing, and they're dividing into 1. All right, so anything divided by itself comes out to be 1, and then those signs aren't going to really matter in this case because we're looking at both positive and negative signs. So in this case, our answer, we end up with 4 possible solutions. We're going to end up with x equals pi over 4. And when x is pi over 4, we're ending up with a positive 1. We get a 3 pi over 4, where it's equal to negative 1. And then we get 5 pi over 4, where it's another positive 1 because negative square root of 2 over 2 divided by negative square root of 2 over 2 is positive 1. And lastly, we get 7 pi over 4. So those are going to be 4 possible solutions. And I'm not going to do it in this video, but if you were to take those solutions and you were to substitute them into x in our original function and check your answer, or if you were to graph this on Desmos or any graphing utility, you would notice that you would end up with these 4 solutions on our interval from 0 to 2 pi. So let's move over here to the secant squared of x. And let's see how this one's going to look. First, I'm going to isolate my trig function by adding 4 to both sides. And I have secant squared of x equal to 4. And then I'm going to do exactly what I did in this previous problem. I'm going to get rid of that square by taking the square root of both sides. So secant of x is equal to, well, square root of 4 is 2, but what you don't want to forget is that positive and negative value. So positive and negative 2 in this case. And then we're going to take our secant of x and we're going to do the inverse trig function of that. So inverse secant or arcsecant. So x equals the inverse of secant of positive or negative 2. So let's think about our values that are making that happen on the unit circle. So on the unit circle, first thing you want to notice is that secant is the reciprocal of cosine. Now cosine are our x values on our unit circle. So our x values on our unit circle, and we want the reciprocal. So if we're doing cosine, let's kind of think backwards. The reciprocal of 2 is 1/2. So where is cosine, or where are the x values going to be 1/2? And that's what we need to find first. We'll get the negatives in a second. So we want it where it's positive 1/2 or negative 1/2, where cosine, the x values on the unit circle, are positive 1/2 or negative 1/2. So that's going to be happening here at these pi over 3 values. Pi over 3, 2 pi over 3, down here and down here. So all the positive and negatives. So 2 pi over 3 and 4 pi over 3 are going to be negative 2s, and then pi over 3 and 5 pi over 3 are going to be positive 2 for secant in this case. So those are going to be 4 solutions for us here. So x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So again, this is a continuation of our last video. If you aren't sure how to isolate those trig functions, you're going to want to do that first. This video is focusing on how to take that square root of both sides, and what you really want to keep in mind, the only thing that this adds is that you're ending up with positive and negative solutions. Alright, so I'm going to move here to these next 2 problems, and I want you to pause the video and see if you can take a stab at these first. Okay, I'm going to zoom through my answers, just fast forward through it, and you can watch how that work gets done and see if you are getting the same answers. So let's do it. Nothing's gonna keep me from finding you. And 7 pi over 4. All right, so in this case, you only got 1 new problem because I didn't realize that the second problem right here is the exact same one as our first example. But if you didn't notice and you got the right answer, congratulations, you did work through that one. But then our first one, we got pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So we really want to keep in mind what are the possible solutions for that positive or that negative value. As you're working through this, keep working through those practice problems. If you're running into any issues while you're going through that, just remember, I'm Mr. Hernandez, and I'm always here to help.